Yesterday we went over the laws themselves and did a few examples, and I just wanted to put this video online to give you some other additional examples of how we can apply the product and quotient laws. So let's look at example A. I have the logarithm of 4 base 8 plus the logarithm of 16 base 8. We can use the product law to combine these two logarithms into one by multiplying 4 and 16. So 4 times 16 is 64. And then now we have one of two ways to do this. We've learned how to evaluate now logarithms with different bases. So you can do that on your calculator. Or we can remember that if we rewrite this, we're looking at 8 to some power is equal to 64. So I think that power is 2. So this whole expression is equal to 2. Example B, we have a logarithm of 405 base 3. Subtract the logarithm of 5 base 3. So here we can combine these into one logarithm by dividing 405 by 5. 405 divided by 5 is 81. So we're looking at the logarithm of 81 base 3. And again, on your calculator, or using the identities of what a logarithm is, 3 to some power equals 81. And that power is 4. Okay, what we do have to remember with the product and quotient rules of logarithms, we can only combine logarithms that have the same base. If they don't have the same base, we can't combine them. Here we'd like to combine these two logarithms together because they have the same base. We're adding them, so we'll be multiplying what's inside the logarithms. The problem is we have to deal with these coefficients. But we can use the power law of logarithms in reverse. Bring those powers up. Evaluate these. This is the logarithm of 25 plus the common logarithm. And remember, powers of 1/2 means square root. So this is the square root of 16, which is 4. So the logarithm of 25 times 4 becomes the logarithm of 100. 10 to some power equals 100 on your calculator, or working algebraically, that would be a final answer of 2. Okay, a few more examples. This time we're going to look at questions involving logarithms and variables rather than straight numbers. We'd like to simplify these three expressions. In example A, there's two ways we can do this. One way would be to use the product law of logarithms to break this up into a logarithm of the square root of x times the logarithm of x squared. So this becomes the logarithm of x to the power of 1/2 minus the logarithm of x squared. We can bring down the powers. And then these logarithms, the log of x and the log of x, x are like terms. We can add them together. So 1/2 take away 2 would be -3 halves times the logarithm of x. That's one method to do this. The other method would be to leave this as one logarithm and use our rules of exponents to simplify what's inside the logarithm function. So I have the logarithm of x to the power of 1/2 minus 2, which is the logarithm of x to the power of -3 halves. And again, using the power rule, we bring that power down, and we're left with -3 halves times the logarithm of x. Same thing on both sides. Question B, what I'm going to do is rewrite all of these terms using exponents. And then I'm going to combine everything into one logarithm. So of x to the power of 3 halves times x squared all over x to the power of 1/2. So I use the product and quotient rules of logarithms to combine this into one logarithm. In the numerator, I can simplify by adding the exponents together. 3 halves plus 2 would be x to the power of 7 halves. And then I'll simplify this again by subtracting the exponents. 7 halves subtract 1/2 is 6 halves, or 3. We're looking at the logarithm of x to the power of 3. And then using the power rule, I'll bring down that power. And my final answer is 3 times the logarithm of x. Finally, example C, I'll combine these two logarithms into one logarithm using the quotient rule. We should factor the numerator and denominator of this logarithm as much as we can. So the numerator is easy. It's just a common factor. The denominator is an example of difference of squares. I can cancel. So my final answer will be the logarithm of 2 over x plus 1. Okay, I hope these additional examples helped. And just a reminder that we will be having a test next week.